Okay, so today we're going to look at recursion. Recursion is when a function calls itself to solve a smaller bit of the problem. This is especially this is especially useful when you're trying to get things done quickly. For example, so let's first make a new file. You can click this new file, then click this, but instead I'm just going to get my already own this. Alright, let's start. So make a function called countdown. Then the parameter should be n. Next, we're going to add an if statement. If n equals 0. If n. Then we're going to print done. Or else print we have to print the parameter n, then count down parenthesis n minus 1. Else print n count down n minus 1. Oops. Then we do the final countdown. Good. So what does this do? So number one, this is the base case. This stops the recursion from happening. Next, this is the recursion call. And this executes the program. Let's start. See? Instead of just printing n and instead of just printing a whole bunch of n's or maybe doing a whole bunch of this, we just recalled our own thing. We recalled our own function. Then I'm going to show you another one. We're going to use this basically the same example. But this time it's much different. Loop 5. Alright, what did we get? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It excluded this. This recursion is especially useful. For example, let's take another example. to try factorial. So we get this. It's it's essentially the same thing. So this is the base case. This returns 1, else this returns n, and and multiplies it by the factorial n minus 1. Then we're gonna print it out. 120. But what is 2? 60. 3? 20. 4? 5. 5? 1. What? It was like this. 2? 1. 1. 15. Bam! 475. 3. And yeah, it died. So we have a recursion error. And that is the tricky part. How do you know if something is within the limit when you don't actually know how to operate a recursion thing? It's easy. Make the error in the first place. Then you can just reback your code. Then you can simply just take a step back and fix your code. What's in here? There is a run and debug in here. Maximum recursion depth reached. This is especially useful in VS Code because it helps know your call stack. And when I say call stack, it means that your history of running these is you can also do this. Load more stack frames. You still have a lot up here. Anyway, now we're going to try this. Let's try making a money printing. I mean a printing machine. You can also type input. You'll tie it to papers. Oops. Six. Hold on. This is a trick to organize things. 7, 7, 6. Aha. And we'll do this. Let's do this. Much better. Now let's see if this works. On papers to print, 5. And type error. We got to convert this to str. Alright. Uh-oh. What? Now this is the problem. You can't, again, you can't convert a function. So how do we do this? It's easy. Since you can't actually convert a function, instead, you can actually do the variable. Let's do variable. Paper. Much better. Oh, whoops. And it's a type error. It didn't work. So that means you can't actually do that. Type error. Now this is the problem. It's all spaghetti coded. Much better. Type error. This is the problem with VS Code. It's always stuck. Ah. Another type error? Dude, this thing is insane. that means you're gonna end up doing this. However, you can still tie it. I'm sure you can. It's super easy. 10 papers. Okay, 3 and 2 and... How many papers to print? 5. Dude. STR and int. Let's try making this into an int. Arg. Ugh. Can you do this? No, you can't. So that's it. There's a whole bunch of errors when you're trying to do that. You have to be pinpoint precise, otherwise you'll get a whole symphony of errors. Anyway, that's the end of our video, and I'll see you, and then we'll be covering classes tomorrow.